Hardwired controllers are systems in which the sequence and the functions are determined by appropriate fixed wiring of the individual elements of the control part. Electrical lines are primarily conductors for electric current, but the arrangement of the various elements and the way they are connected determines the function of the system. Changing the program sequence requires a change to the wiring. The pin assignment of a relay determines the logical function. In the case of a normally open contact, input signal at the coil leads to output signal at the contact. That is logical function identity. In the case of a normally closed contact, input signal at the coil leads to no output signal at the contact. That is negation, or a logical knot. In this elevator, we can see hardwired logical associations for the control of the hydraulic power part. The elevator only travels when the push button has been pressed and the elevator door has closed. This is a logical AND. And this is how it is shown in the circuit diagram. If the two switch elements with their normally open contacts are connected in series, current can only flow when both contacts are closed. This is an AND function. Push button and door contact. This is another logical association. The elevator can be set in motion from inside or from outside. The circuit diagram again has two normally open contacts, but this time they are connected in parallel. It is sufficient from one or the other to be closed in order for current to flow. This is a logical OR. Electrical signal latching is needed when spring return valves are used, because in this case the signal must remain present as long as the valve is to remain in the switched position. In addition, the position can be indicated by a signal lamp. This requirement can easily be met with a self-latching relay. When push-button S1 is pressed, relay K1 picks up and the two contacts K1 close. One keeps the relay coil energized and the other switches current to the solenoid valve. This means that the relay remains in this position, even if contact S1 is opened, until S2 is opened. If S1 and S2 are actuated simultaneously, the relay coil remains energized. This is called a dominant on latch. An example. In this circuit, the on signal remains effective even if the off signal is given at the same time. This means that the machine step is automatically completed once started. This is another latch circuit. But in this case, the off push button S2 is not connected in parallel as before, but in series to push button S1. This means that the circuit is interrupted if S2 is pressed, regardless of the position of S1. This is called a dominant off latch. Here the cylinder retracts immediately if the off signal is given, even if the on signal is still present. Machines may require this kind of latch for safety reasons.